Okay guys, so this is going to be our lesson over evaluating expressions involving inverse trig example problems. Now for this lesson, it's super important that you realize that inverse sine and inverse tangent are defined in quadrant 1 and 1 and 4. So it's positive in quadrant 1 and negative in quadrant 4. Inverse cosine is the weird one. It's positive in quadrant 1 and it's negative in quadrant 2. So whenever you're doing inverse trig, there's only 2 quadrants involved. Okay, when we're talking about inverse trig, we're looking for an angle. When we're doing regular trig ratios, we're finding a ratio, okay? So what we're going to be doing here is we're going to be going backwards. So you need your trig chart if you got it in front of you. Okay, so the first example problem, what this is asking is, at what angle is sine equal to 1? Okay, so sine is equal to 1 at pi over 2. And we're going to be in radians for all of these, so let's just do, and we'll write radians, so you have a record of that. Okay, so these are all going to be in radians, and that's it. That's all there is to it. Next question, it says arc sine of negative 1/2. So inverse trig can be written 2 ways, just depending on which book you're looking at. It can be written as inverse sine, like that, or it can be written as arc sine. They both mean the same exact thing. Okay, so we're going to ask ourselves, at what angle is sine equal to 1/2? Okay, so sine is equal to 1/2 at pi over 6. Okay, now since it's negative, we have to have a quadrant 4 answer, so we're going to say it's negative pi over 6. Now, remember that if I go this direction with the negative angle, it puts me in quadrant 4. If you wrote 11 pi over 6, it's the same answer. If you were going to put this in the calculator, if I was to put this in the calculator, I would do second sine of negative 1/2. And it would return that, and pi over 6 is 0.52, okay? Try to get a little more light in here. Okay, so next example problem. It says, where is cosine equal to negative square root of 2 over 2? Okay, so cosine is equal to square root of 2 over 2 at pi over 4, or 45 degrees. Okay, so we're going to write that. Now, it's negative. So inverse cosine is defined in quadrant 1 and quadrant 2. It has to be negative in quadrant 2, so we have to get a quadrant 2 answer. So remember, if we're in fourths, this is 4 pi over 4 over here. So that means that in order to get a quadrant 2 answer, it would be 3 pi over 4. So that'll put you in quadrant 2. Okay, arctangent of negative square root of 3. Arctangent of square root of 3 is pi over 3 radians. And it's negative, so arctangent is defined in quadrant 1 and quadrant 4, so it's negative in quadrant 4, so we just stick a negative sign. The only ones that are weird are cosine. So otherwise you just stick a negative sign in front of it. Okay, cosine of pi over 12. Now, when we have multiple functions like this, we're going to work inside out. Okay, so cosine of pi over 12, that puts us in quadrant 1. So that's important, so I'm going to write quadrant 1. Because 6 pi over 12 would be pi over 2, so it's just going to put us in quadrant 1. Now, what happens when you do inverse cosine of cosine? It's going to cancel each other out, okay? So, especially if it's just in quadrant 1, you're good to just write pi over 12. Okay. Sine of 5 pi over 4. Well, we can evaluate that pretty easy because we know how to use our trig chart. Okay, so if I'm going to draw this out, sine of 5 pi over 4, 5 pi over 4 is going to land us in quadrant 3, because this is 4 pi over 4. And this would be 8 pi over 4 on this side. So it's quadrant 3. Your reference angle would be pi over 4. Go to our trig chart, it'd be square root of 2 over 2, and it would be negative square root of 2 over 2. So what I'm going to do is I'm just going to write that in there like that. So that's what this means right there. Okay, now I'm going to do inverse sine of square root of 2 over 2. Okay, so at what angle is sine equal to a square root of 2 over 2? Well, it's pi over 4. And it's negative, so we write negative pi over 4. Remember that when we're dealing, the only one we have to worry about doing quadrant 2 on is going to be cosine. Arc tangent of 1/2. So we haven't had to deal with any that have inverse trig on the inside. So let's deal with it in a little bit different way. So when we have inverse trig on the inside, we're going to draw a right triangle using our vector trig that we learned. Now, arc tangent is going to be positive, so we're going to draw it to quadrant 1. Okay, and I'm going to draw a theta right there. Okay, tangent is opposite over adjacent, so we're going to put a 1 here, a 2 here. Do a Pythagorean theorem. 1 squared plus 2 squared is equal to c squared. So we get 5 is equal to c squared, so c comes out to be square root of 5. Like that. So once we set that up, we're going to evaluate sine. Okay? So sine of this is going to be opposite over hypotenuse. So it's going to be 1 over square root of 5. That's your answer. So we're always working inside out. Next one, we have inverse trig on the inside. Okay, it's negative, so we're going to draw it to quadrant 4 for sine. Okay, sine is going to be opposite over hypotenuse. And remember, the hypotenuse is never negative when we do our little right triangle. Okay, so we're going to do Pythagorean theorem. Negative 1 squared plus b squared is equal to 3 squared. So b comes out to be square root of 8. Remember, in quadrant 4, you have a positive x and a negative y. Now we're going to evaluate the cosine, because that's what it says to do. So cosine's adjacent over hypotenuse, so it's going to be square root of 8 over 3. Like that. Okay, now we're going to go into the back page. So we only really do the triangle stuff whenever it's not on the trig chart. So just keep that in mind. Okay, inverse cosine of negative 1/3. Okay, arc cosine or inverse cosine is defined in quadrant 2. So we draw a little triangle up to quadrant 2. And inverse cosine is adjacent over hypotenuse. Okay, we're going to do Pythagorean theorem to find the third side. So we're going to do negative 1 squared plus b squared is equal to 3 squared. So it's 9. So this is square root of 8. Remember, in quadrant 2, it's negative x, positive y. Now we're going to do tangent, because it says to do tangent right here. So it's going to be opposite over adjacent. So it's negative square root of 8 over 1. And that's my answer. Okay. Arc tangent of 1. Well, 1 is on our trig chart. So arc tangent of 1 is pi over 4. So I'm just going to kind of cross that out and do pi over 4 like that. Cosecant of pi over 4 is square root of 2. So my answer just becomes square root of 2. And the last one. Inverse cosine of negative square root of 3 over 3. Now, this isn't on the trig chart for cosine, so I'm going to draw my triangles. And you draw your triangles whenever we have inverse trig on the inside. Okay? Make sure your angle is always with the x-axis. Now, cosine is going to be adjacent over hypotenuse. We're going to do our Pythagorean theorem to find the third side. So we get square root of 6. And it should be positive because in quadrant 2, you have a negative x, positive y. Okay, so this says we're going to evaluate cotangent. So cotangent is going to be adjacent over opposite. So it's a negative square root of 3 over square root of 6. Or if you want to write it as one fraction, be my guest. And if you want to simplify it, that's fine with me, either way. Okay? So that's been in evaluating inverse trig. Expressions, remember that inverse sine and inverse tangent are defined in quadrant 1 and 4, and inverse cosine is defined in quadrant 1 and 2. We're going to work inside out. Make sure that if you see arc is the same thing as inverse. Okay? So, if you have any questions, feel free to reach out. Thanks, and have a good night.